In the last video I had two LEDs flashing back and forth. Now I've added 4 more LEDs to this and I've made a bit of a chaser. If I go start simulation, you'll see that the LEDs are going in a sequence. So similar to the ones that were just flashing before, but now it's going across all of them. If we look at the code for this, you'll see that I've set up 6 different pin modes and I've set them all to output. So 13 through 8 are all listed as outputs. And down here, if in my actual void loop, you can see that in the code, I've said digital write 13 high, then low, 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 low. Now then I've got the delay and then another group. This is not the easiest way to do this, but from an entry-level point of view, it's probably the easiest to understand. So you can see in the blocks that on each block, the next LED is high. Now, what I might want to do with this is control the speed at which these are changing mechanically, not just in the code. To do that, I would have to add a potentiometer. So I'm just going to stop simulation, which you have to do before you edit anything. And I'm going to add this potentiometer here and stick it on the board. Now, with the potentiometer, it's got 3 pins. One pin needs to be connected to 5 volts. I'll set that to red. One pin needs to be connected to ground. We're going to set that to black. And one pin needs to be connected to analog in. So as opposed to let's zoom in on that, make sure it works. As opposed to a digital signal, which is just on and off, an analog signal allows you to have a value between 0 and 1023. Meaning I can take that 0 to 1023 value and apply it to the delay between these LEDs. So let's jump back to code for a second now that we've got the mechanical part done. Now we do not need to have a pin mode for potentiometer because it's using A0. As long as we're using the analog ins, by default they are set to an input. If we were using a digital in though, we would have to say pin mode input. What we do need to do though is set up 2 integers. So an integer is something that's going to carry a value. The first one is going to be setting this as a 0 value, and the other one is going to be naming A0. So up here in my code, I can say integer pot, so for potentiometer, equals A0, semicolon. So that's changed the name of A0 to pot. And I can say integer pot value equals 0. And what that's going to do is we're going to assign pot value to pot later on, but it's going to say that when this code starts, pot value equals 0 until it can read what the potentiometer says. Down here in the void loop, we're actually going to read it. And to do that, we're going to go analog read. And notice that the R is capitalized. This is just C formatting where the first word is lowercase and the second word is uppercase because you can't have a space. It just helps us figure out what the terms are. So I want to analog read pot, like so, semicolon. So that's going to read it, but it's not going to do anything to it. So I actually need to assign analog read pot to the pot value. To do that, I'm going to say pot value here equals, not minus equals analog pot, just like that. I'm just going to start simulation to see if it works, looking for any red lines that are errors. Now, again, nothing has changed here. This is not controlling the circuit at all yet, but I have assigned this pot value. So let's stop simulation again. And I'm going to copy pot value, so control copy, and I'm going to just stick it in all of these delays. So there we go. So now we've got pot value between each of the delays. I'm going to go start simulation again, and now this time when I change the potentiometer, it will change the speed that these are going. So now you've got a mechanical way of managing the speed of those LEDs. Analog inputs could be used for a number of other things, but this is just one example.